From the bathroom. He says bathrooms are the biggest water guzzlers. His idea is to reclaim some of that water and reuse it. Although the idea may not be all that original, the system that makes it work is.
30% of water going down the toilet drain every time you flush. The shower takes about 30 to 40 gallons per person. The bath takes even more. In this position, the green light indicates that the unit is ready to recycle.
Once you flick on the switch, it starts working. Jones gave us a demonstration. The draining water from the bathtub is channeled into a chlorination tank. From there, it's pumped upwards and filtered not once, but twice. It's then pumped into a holding tank. This reclaimed water can then be used for flushing toilets and watering the landscape.
If you can selectively choose those waters, the fresh water that goes down your waste, and reuse it in a sense. Like I haven't used dirty water, fresh water in my toilet since January of this year. All of the water's been reconditioned water, reclaimed water.
My name is Edward David Jones. I'm an author, I'm an inventor. I started an organization named OMT Systems, One Man's Trash, Other Man's Treasure. My forte is food waste. It's a devastating effect on Earth. In the capacity of food waste, my studies have shown me that liquid waste is worse on the environment than solid waste. In that capacity, for the last 30 years, I've written a book about food waste and what it's doing into the earth, and I've invented a machine that I think will alleviate some of the liquid waste that we humans intentionally throw into the garbage bag. I've invented a system that separates ice from the things that we drink. The system separates the ice, it channels it into one chamber where it is melted. It's melted and then filtered, chlorinated, and pumped into a holding tank where we can disperse it into a toilet or a lawn application. Who needs to urinate in fresh water? So with that thinking, with that capacity, reduce, reuse, and recycle is my forte. That's my story, and I'm saying.
My name is David Jones, and I want to introduce to you my new invention. It's called a water reclamation canister, or basically a liquid waste can. It's a wastewater monitoring system. It monitors all instances of water that we waste in the shower, in a restaurant. This is the book that I wrote about it. I used the title, The After Meal, because the word after meal is all encompassing. It encompasses insects that crawl upon the earth's surface. It encompasses single-use items, the straws, knives and forks, the plastic single-use items, condiments, and the cups. In this book, I describe a little bit more about this product. This book was published in 2017. I've been writing and conceiving about this product for the last 20-something years. I've been working on it. This product is a combination of a waste management system, water reclamation, and water recycling systems all combined in one. This is the cover. I'm gonna just take it off. It represents chamber 1, where most of the ice is collected and potable water is collected. For example, every time you go to a restaurant, the waitress gives you that water with ice in it that you don't drink. After you don't drink it, this is the kind of a machine, a liquid waste receptacle that we need. We take our cup, empty it out, and stack the cup up. If the cup has ice in it, you pour it in Wally Well's mouth. Wally Well separates that ice from the machine, the cup. If you are drinking milk, for example, you pour it in. Once you get and the ice that's in the milk would separate, And if you had a straw in your cup, you take your straw out and stack it separately. You'd empty your cup into Wally Well's mouth. The ice separates, comes into chamber 1, and you stack your cup. So what we've got is all the straws, knives and forks and condiments, single-use items stacked up through the top. And a little orange juice. I hate to throw this away, but that's how we do it. So this is the system without the covers. This is what it looks like. And a little peep inside, you see the ice that we separated. It's the back of the unit. So the unit has, machine comes on, it actually starts cleaning out this section. It sends water down there for 30 seconds and it'll clean this section out. Then it starts acting on the ice. For 1 minute, the machine is going to process this ice, melting it, cleaning it out, and melting the ice. Once the ice is all melted, in about a minute or two, it'll start processing the water and kicking out nothing but clean water to the holding tanks. We're going to watch it work here for a little. This is how it melts the ice. Ice is going down. It cuts off after about a minute of processing, and it starts kicking that water out as processed water into the storage tank. And it sits there and waits until we get more water to process, chlorinate, filter, kick out into the storage tank. We can also set up filtering units that process the water once it starts cycling and cleaning itself out. As gray water can only be held around for a 28-hour period, it must be continually recycled, rechlorinated. This machine acts just as a swimming pool does on the water that it gets out. This is all water that we save from wastewater. We're using wastewater to generate a source of water for toilet and lawn applications with the system. This machine is totally programmable and can be interfaced from the web so that we can remotely monitor and control every device in the home that this machine is connected up to. This is the base, bare necessity for an intelligent home. Intelligent homes must be ones that can dictate and mandate what happens with water, gray water. Input and output valve, that blue tube is connected to the sewer. The green line are input and the other line is output lines. And they're connected up to our demo. This would represent the storage tank, empty right now. This would represent, say, a kitchen sink, where everywhere we collect water, a tub. What if this was a shower, for example? We would be collecting water. We put sensors in here. We've got laser sensors, optical sensors that'll tell us if the water's cloudy or not. If it's cloudy, we let it go into the drain. If it's clear, straight gray water, we'll recycle it to this tank. Oftentimes, we get water into the system through the rear end, and not just with potable water that's deposited into this with wastewater, ice and stuff like that, but we get water from our kitchen by using our proprietary filtering system. We've run a cable that goes into our kitchen, and this is it. It is actually connected as an auxiliary drain. That's the primary drain going to the sewer. This is the drain going into our system. Our proprietary switch float sensor is connected up to a cable that's connected up to the water wheel. And we're going to run some water. And as soon as that water makes contact with the sensors in that switch, it's going to turn on the system. And we're going to see the system that just came on. The system is now going to transfer the water from the kitchen drain into our storage unit. All of the water from the kitchen is going through this filtering system. It is bypassing the normal sewer or hole and going in our system. This is reclaimable water. You would wash your hands, or you can rinse off the rest of your dirty dishes with this water, or do whatever you want to do with it. But this is the water that we saved from tap to drain. It's being recycled. Filtered first. We captured it. Hey, how you doing, buddies? And we're now recycling it into our storage. And that is our demo of the water wheels. And this is a rain barrel, 55-gallon rain barrel where we collect rainwater. It's connected to switches as well. And we can suck that water into the same system, chlorinate it, filter it, and pump it out to the holding tank for later uses. This is a sample of that system. This is the switch that controls it. Okay. The first 2 minutes of every shower is clear water going straight down the drain. We can time the drain to 2 minutes of that water going straight into the system, being collected, cleaned, filtered. There's a filtering unit inside of this system. Filters it, pumps it up to the storage tank. Let's watch a shower simulated. We can time this shower to go for 2 minutes, the first 2 minutes of your shower, collecting all of the fresh water that would normally go down the drain into this system where it will be processed, filtered, chlorinated out. Just to once again simulate the front end of the machine, we can manually control it. If there were ice in there, it would actually melt the ice and come on and act like that. The first 30 seconds, the water will go down and towards cleaning out the unit. This is the clean out section, which is connected to the sewer system. 30 seconds, then the machine will focus on melting the ice and running on chlorination tablets, chlorinating the water for about a minute. It is processing the water inside of the machine. It is turning on itself, filtering, processing the water. After 1 minute, it start kicking that water out into the holding tank after it is finished processing it.
After the storage unit has so much water in it, the system will sense that by floats that control the water level in this storage unit, and it will start pumping the water out into the lawn via our sprinkler system, which is working. That's because of this storage unit overflowing. That's what happens to the water. And that is our little demo. Happy saving your water from your shower.